Hi there, this is a quick video about a recent eBay purchase. I was really looking for a network cable tester, but when I saw this wire tracer cable tester, I thought, hey, this does this and it allows tracing cables using an audible signal. And when I bought it about 2 weeks ago, the price was right. Just shy of £12 delivered, that's about $16. Now I just saw the vendor has doubled the price, which is way too expensive. But the same thing is available from other places if you really want it. The question is, of course, should you? It came in a stable enough cardboard box and the outside sports these labels. I pause for a moment if you want to read it. Anyway, there are two stub cables. One is a short RJ45 network cable and the other one has an RJ11 phone style connector on one side and two alligator clips on the other. The two items, let's call them transmitter and receiver, are in a bubble wrap bag. And there is, surprisingly enough, an actual manual in 4 languages. That manual turns out to be the usual terrible translation from Chinese and often more confusing than helpful. Both devices were very light, which means no batteries on board. Fair enough for the price. Opening the compartment of the transmitter unit reveals a metal threaded insert for the screw, which is nice, and that a 9-volt battery is needed. The compartment for the receiver also has a metal threaded insert for the screw holding the battery door and a clip for a 9-volt battery. The compartment is quite tight and you have to squeeze the battery into it. It does turn out that the receiver only needs a battery for the audio signal tracing and the built-in torchlight. During network cable wiring tests, it's powered by the transmitter through the network cable. Also, I checked the battery consumption and it was about 10 milliamps for the transmitter, which is acceptable. The receiver needs a bit more, about 20 milliamps for the audio and another 20 milliamps if you use the torchlights. Anyway, with batteries in both devices, it's time for some tests. I plugged a network cable into the RJ45 port of the transmitter and selected the first mode called scan, which would be better called tracing because that is what it does. It inserts a tone into a network cable and with the receiver you can find out which one it is from a bunch of cables. Of course, this makes more sense if you have a bunch of similar looking cables in one room and you want to find out the matching one in some other room or cable duct. The other test for network cables is testing for broken, shorted or swapped conductors. For this, the cable to be tested needs to be plugged into both transmitter and receiver and network selected. The test button starts the transmitter to send a DC signal to each of the conductors one by one, causing the corresponding LED to light on the transmitter. If the cable is okay and wired straight, the LEDs on the receiver light up in the same sequence. That is all the tests you can do with network cables, so I changed over to the RJ11 socket with the provided test lead. I selected tone in the expectation that this provides the cable tracing, but no, the receiver stays silent. The manual is very confusing about this. The tracing function for the RJ11 socket is available by using again the scan setting, and it works just like the one for network cables. The last setting is cont, which turns out to be simply a continuity test. If I touch the two RJ11 alligator clips together, the green cont light turns on. But the definition of continuity is rather generous, as you can see here in this test where I put increasing resistance values between the alligator clips. 100K and finally dims the light a little. And 1 meg makes it so dim that we may call it off. Given that range, I wonder how it will bear out in actual usage, but I'm glad I tested this because it could lead to unexpected results. So, what about the mysterious tone then? It turns out that this is basically a voltage test for telephone lines. No idea why they call it tone. If I connect 12 volts DC plus to the red clip and ground to the black, the tone LED lights dimly red. Reversing the polarity makes it dimly green, so dim it's actually hard to see. But since plain old telephone operates usually with much higher voltages, let me increase the voltage to 30 volts. Still not particularly bright, but visible. Reversing the voltage again shows the red LED is much brighter. Anyway, some phones work with 60 volts, so the circuit is probably catering for that. According to the manual, this function allows you to deduce certain facts of the phone line under test, like if the phone is off the hook or ringing, but that would probably depend a lot on the phone system in question. Let's have a look inside. The transmitter unit first, which is held closed by 4 self-tappers. To get the back shell off, the battery connector has to be pushed through a hole. Not much inside. Everything is done by this microcontroller without any markings. Interestingly, there is apparently provisions for adding a BNC connector. I did not bother tracing this out, but the main thing is to note that apparently from a few beefier diodes there is no protection whatsoever. This means one needs to make sure that the tested cables are not under power, certainly no higher voltages. I am thinking of power over Ethernet, for example. There are 2 self-tappers on the receiver back shell, but that does not let you open the receiver. After searching in vain for a clip mechanism, I finally suspected the QA sticker. And of course, they put that right over the 3rd screw. There's a tiny speaker connected to the PCB, which also has the connection to an earphone and the torchlight LED. The amplifier circuit itself is on the other side. Right in the middle you can see the 3 solder joints for the potentiometer controlling the volume. The other solder joints are for the 3 push buttons, on-off at the front, then torchlight, and finally the scan button turning the amplifier on for tracing. The 9 LEDs for the network wiring test are on a separate board, and it's only connected to the RJ45 socket at the back. It does not need any of the other circuit in the receiver or its battery power. I tried very hard to get the volume knob off without breaking it, because that prevents the amplifier board from coming out for a closer inspection of the other side, and finally gave up. It might be glued on. I think the only way is to desolder the volume potentiometer from the circuit board, and sorry, that was more effort I was willing to do. It's likely a no-name integrated amplifier and not that interesting anyway. There are 2 LEDs on the receiver front, both green here. Well, one is the power on indicator, but what is the other for? I think it's supposed to be an indicator for signal strength, and it turns red sometimes, but as you can see it's not very well implemented. It is really confusing. After playing around with it for a bit, I decided to ignore both LEDs. I mean, you can hear if the signal is louder or weaker, and if you are working in a noisy environment, just use the earphone socket. By the way, the receiver is largely immune to cables running mains voltage, which led me to have a look at what signal is actually sent by the transmitter. I suspect the receiver uses a high-pass filter to avoid picking up mains hum. Turns out it's an FM modulated square wave with an amplitude of 6.5 volts and varying roughly between 2.5 and 3.2 kHz. It is a DC signal, and this was measured by connecting the black alligator clip to the scope input and the red one to ground. I set my signal generator to produce a roughly 1 volt 1 kHz sine wave in the yellow wire, and the receiver is able to pick that up. With increasing frequency it gets louder and louder as we get into the frequency range used by the transmitter. Going the other way on frequency, the signal gets weaker and becomes inaudible well before reaching mains frequency. It is just random noise being picked up, but changing from sine wave to rectangular and the signal is back. That's because the rich harmonics in a rectangular wave. So overall, I think this is not a bad tester considering the price. Well, what I paid, not what the seller wants now. The important thing to remember is that the tester has no protection. Understand, what you get is what you pay for. This unit is for hobbyists and not for professional installers or network engineers. If there's any doubt, you have to act and not plug it in blindly. A capacitor in series with the alligator clips can be used to inject the tracing signal safely into cables where you're not 100% sure what's on the other end. For tracing network cables, I got myself one of these adapters. Once you know the other end of the cable, you can unplug it and connect it directly to receiver and transmitter to do the network test. If you like my videos, don't forget to like and subscribe and help growing this channel, and consider becoming a Patreon. The link's in the description. Thanks for watching.